Thank you very much. Thanks for coming. Thank you for your time this afternoon. My name is Matthew Baldassano. You can call me Matt. You guys were probably here for one or two reasons. One, that you know CommScope and you're looking to see what the next stuff is kind of on the horizon. Or two, you picked out the title from some of the trends and some of the networking protocols and speeds that we're starting to see in the data center today. So the title of the presentation is 4100 gigabit Ethernet Next Generation Architectures Managed Intelligently. Some of you guys are here. I expected about this amount of people. It's late in the day. We're being video recorded right now, and I suspect most of the people that were going to be here probably said, we'll just catch us on the back end later next week. I'll stream the file from my office. They're the reason why we're having this conversation today about upgrading our networking. So just a couple of drivers for more bandwidth in the data center and the enterprise office and campus as well. There's a bunch here. I like to focus on three: high-performance computing, server virtualization, and my favorite, LAN on motherboard. Right. So LAN on motherboard is or 10 gig LAN on motherboard are NICs that are now being basically essentially offered for free or for very low cost, which are driving speeds higher up into the network. Cabling can have a major impact on the success of the implementation of some of these applications. So let's take a second and talk about some of the similarities between computer rooms, campus computer rooms, and data centers. If you worked in campus environments before, we have access control, heating, lighting, security, a plethora of protocols that are now starting to be combined over IP, running back to a centralized server or computer room that has storage, servers, and networking. Most of our data centers, or all of our data centers, also have storage, servers, and networking, but they have some operating efficiencies that some of these computer rooms are starting to borrow now. Recently, and you guys may have the white paper in your hands, CommScope started talking about 4100 gig in the campus and in the data center. And we came up, there's a couple of different facts in there. One that kind of pops out to me is 55% of your switching equipment can be protected, and 57% of your fiber cabling can be protected if you do it the right way. So why are we talking about 4100 gig already? Why are we writing white papers on this? This slide's a great data point because it really shows the rate at which your core networking equipment is growing as compared to your access or server networking equipment. So server access is doubling every 24 months, and core is growing at a slightly faster rate every 18 months. This particular slide here, we talk about gigabit Ethernet coming in the core and in the access 10 to 15 years ago. We've upgraded to 10 gigabit, and that was easy, right? 2 fibers, same connector, same patch cords. Just replace the transceivers. You go from 1 gig to 10 gig. Pretty much everything stays the same. So what's the big deal about migrating from 10 gig to 40 and 100 gig? There's a major, major, major impact on the cabling infrastructure from a duplex transmission to a parallel transmission. So this is kind of a busy slide here. I want you to focus. There's really 3 points to this particular slide I want to make. The first, third from the bottom, number of fibers. 1 gig to 10 gig, 2 fibers. 10 gig to 40 gig, you start working on a 12 fiber backbone. And then when you go to 100 gig, you start working on a 12/24 fiber backbone. And the reason I say 12/24 is because traditionally in the industry over the last 10 to 15 years, we've actually seen we've seen 12 fiber implementations versus 24 or 48 fiber actual cable. So the connector of choice in the industry today is called an MPO. It stands for a multi-fiber push-on connector, and it's based on a 12 fiber increment today. Now it can be a 24 fiber increment in the future, and we'll see one of the applications for that. So duplex, 2 fibers, and it has a certain form factor. As you move to 40 and 100 gig, now the IEEE did us a favor and they said we're going to use the same connector for both 40 and 100. We're just going to use different number of fibers in a 40. We're going to use 8 fibers in the 40. Those are the 4 outside lanes of those 12 fibers. And within 100, there's a couple different options. We need 20 fibers. We need 10 transmit and 10 receive. And that can be done in a series of 2 12-fiber connections or 1 24-fiber connection. So we start to get a little bit, it's not the same as you move from 40, and really 100 gig hasn't been worked out right now. But to me, the biggest impact that I tell my end users, I tell my consultants, I tell my designers is the distances between 10 gig are significantly higher than what the standard is allowing for on 40 and 100 gig. You're allowed for 300 meters and 550 meters, depending on the grade of multimode fiber for 10. And you're at 100 meters or 125 to 150 asterisks. That confuses people. How could a standard give an option between 125 and 150? Well, that asterisk is 150 meters requires low-loss connectors. Well, now you have to start managing standard loss connectors and low-loss connectors in your environment to achieve 25 more meters. Recently, over the last couple of months, the industry has kind of pushed back and said, we need more than relaxed, lower-cost transceivers. We need something closer to 300 and 550 meters. So what has recently come to the market is something called an extended reach Qsfp transceiver. So this is how we're extending the reach of multi-mode transceivers, and we'll get to the comparison of multi-mode and single mode in a couple of slides from here. So we're able to deliver 40 gig speeds at 10 gig distances. However, this is a tremendous however. It requires the use of pre-terminated, pre-tested cabling to achieve that. And the reason is, well, why can't I just do it the old way? The tolerances that the standard allows for, and I'm not going to get into the certain specifics of what the dB loss is between OM3 and OM4, but the tolerances between 10 gig and 40 and 100 gig, 40 and 100 gig tolerances are considerably tighter. And when you have a tighter tolerance, there's more room for error and contamination if performed in the field. So, simple schematic of a 40 gig link, extended reach. What does it look like? You have Qsfps on the outside. You have a 12-fiber cable that runs between them. This is a very simplified version. But we said 10 gig, right? So how does a Qsfp deliver 10 gig? So how does that work, right? So what we're showing here is a Qsfp can be configured to output 4 individual 10 gig links that then, on the other side of the equipment, equate to 4 duplex SFP or SFP plus connections, running from 300 meters on OM4 and OM3 to 400 meters on OM4, right? So we're much closer to those 300, 550. We're meeting it at OM3, and we're slightly below it at OM4. So this is standard versus extended reach, and I have a next part of the slide is a particular product. It's a Cisco product. It shows you the actual distances that they guarantee, and there's other manufacturers that also produce extended reach Qsfp 40 gig transceivers. 2 key points. Distance is dependent, so you have to use the extended reach transceivers on both sides of the channel, and multiple vendors support these standard reach and extended reach transceivers. What's highlighted here is the support for 300 and 400 meters. Just above that, we see the 100 and 150 meters with the asterisks as well, and that asterisk is the same asterisk that I showed before. And not to say that Cisco's the only one out there that does this. Avago, Finisar, Delforce, Arista, Ixia, and several others actually do. So we're not here to promote the people that sell the optics. We're here to say that the industry, from an optical transceiver perspective, is behind this extended reach distances. So how do we actually migrate what does it look like from 10 gig to 40 and 100 using structured cabling? I mean, what is this actually, what are we looking at here? So as we move from 10 gig to 40 and 100, we're going to notice that the two 12-fiber trunk cables, which are your backbone cables, will stay the same. And keep this in mind, because this plays in the part of your guys' migration strategy from existing 10 gig and 100 gig. Don't be so worried about the fan-outs on the top and bottom. They get, essentially, the magic happens under the covers, and your 12-fiber connector is converted to duplex LC connectors on the front. Out of the duplex LC connectors, we have Qsfp plus optics, and this is your standard 10 gig link today using structured cabling. We're allowed to go 300 meters or 550 meters, respectively, and this is pretty commonplace today. So as we move to a 10 gig with Qsfp, in that slide that I just showed, that one Qsfp going to 4 duplex LCs, how do we get there? Well, when we talked about I guess the 40 gig standard, we said 8 fibers, right? 4 in the outside lane, 4 in the outside lane, 4 blank in the middle. In the development over the last couple of years, we've spoken with some of our customers, and they said, well, do I lose 33 or 30 some odd percent of my fiber going with the 12-fiber connector? I want to be able to use 100% of my fiber. How can I achieve that? And essentially, you can achieve that the same way that you can achieve 12-fiber connectors to a 2-fiber connector. You just drop in 2 12-fiber connectors in the back, and you come out with 3 8-fiber connectors in the front. So you would add essentially another 40 gig connection point on the same piece of infrastructure. So what does that look like? Qsfp at the top, 12-fiber patch cord going into your permanent link. And as we start adding other 10 gig links, we start adding more Qsfp pluses on the optic side of the network. So this is our SR4. This is 100 meters or 150 meters based on the standard. When we move to CSR4, we're seeing 300 and 400 meters. The same, so the distance is dependent. Now, we just said, well, we're migrating from 10 gig to 40 gig. Now, this migration is actually going to happen now. So we're putting in 40 gig optics. We've essentially replaced the bottom module with a Qsfp module. And we're looking at what does that look like. So the distance is dependent between the SR4 and CSR4 in here. However, you still have the ability to do 10 gig over the same infrastructure, as shown right here. So what about 100 gig? What does that look like? Well, there's different flavors of 100 gig. Shown right here is 100 gig using 12 fiber increments in 2 ports. So one of your ports is receive, one of your ports is transmit, and on the bottom you transmit and receive as well. But that's only one variation. The second variation, but not the last variation, is something we saw before, which is a 24-fiber interface. So how do you take 2 12-fiber individual links and make them, and actually seat that into a 24-fiber interface? You need to transition those 2 particular trunk cables to what we call a Y cable, what the industry calls a Y cable. And that Y cable allows you to basically put 24 fibers into a 12 fibers on the top and 12 fibers on the bottom configuration, achieving your 100 gig that way. So when we say, how do we manage this? We just showed, some people may be familiar with structured cabling, and that may be a kind of an overview. I'm sure for most of you people, you're confused, you're concerned, you have other questions about how do we manage multi-form factor networks effectively? How do we know if we have enough LC ports or 8-fiber Qsfp ports or 12-fiber MPO ports or 24-fiber 100 gig ports? So I read a white paper recently, and there were a couple of questions from this white paper. The white paper actually posed questions to the user. So what are some of the factors that you guys out there are going to use when you determine, do I use one 40 gig link or multiple 10 gig links to achieve the throughput that I need? What type of hardware needs to be installed? What type of cabling needs to be installed or reconfigured? Do I have OM3 or do I have OM4? What are the distances I'm trying to push? Do I have structured cabling, pre-terminated structured cabling in my environment right now? Do I have standard field-terminated cabling? And really, what are some of the alternatives at 40 gig, right? Do I stay multi-mode? Am I within the distance? Am I within the power budget to stay multi-mode? Or do I move to single mode? So this particular slide should further confuse you, or further, I guess, emphasize the different types of both multi-form factor connectors and different types of media that live in different places. So typically copper, traditionally, is a short-reach media up to 100 meters, traditionally used in the data center and the enterprise LAN. As we see some of these higher speeds, 40 and 100 gig, the transmission protocols today require multi-mode or single-mode fiber in the data center and in the campus. Single mode, as we see in some of these instances, are really, really long distances, so we're looking at outside plant for single mode. What we're trying to do is we're trying to maintain the lower cost, lower power multi-mode, or the industry is trying to maintain lower cost, lower power multi-mode in environments where multi-mode currently exists today, which is primarily the data center. You may have some single mode, but for the most part, if you ask yourself, what's the ratio of single mode to multi-mode in your data center, I'm pretty confident there's going to be more multi-mode versus single mode, just because of the cost considerations of the optics. So how do we manage this? What are some of the, what do we do to actually manage the, how do we manage multi-mode, single mode, LC, MPO, even RJ45 if we're talking about copper? What are some of the benefits of an intelligent physical view? Shown here is a screenshot. It's a 3-pane database. It's part of a system. It's part of what the industry calls intelligent infrastructure. Our version of intelligent infrastructure, CommScope's version, shows a 3-pane interface. We have a hierarchical view on the left that shows your campus, your city, your office building, your room, your floor. So basically shows you where in a hierarchy these objects that sit in the middle, and these objects all have properties that you can either custom define or take some of the defaults on. And what I like to see the most is in the right-hand pane, we actually see a rack-level view. And there's ability to drag and drop between these panes to install or to commission or to decommission infrastructure in your network. So that's several benefits. I think this is one of the more important benefits. Second very important benefit is a top-down bird's-eye view. So when we talk about layer 1, physical layer 1, typically there's a blind spot to what port in that outlet is connected to a certain switch. We know IP, we know DNS, we know a lot of layer 2 and layer 3 information, right? But unless we have accurate records that we can feel confident on, there's always a double check. Hey, can you go double check and make sure that this switch port is patched into a particular port that I think it's in. Let's go get that rogue access point, right? We know it's on a certain switch port, but we really don't know in the office what what port, what outlet that's coming out of. So a top-down view allows you to actually import drawings, AutoCAD drawings, building drawings, map drawings, and then overlay by dragging objects onto those drawings. So essentially you're going from layer 1 all the way up the stack and seeing physically where your objects are located in a real-time view. As those objects move, as those soft IP phones move from office to office, database is updated automatically. So how does this relate to intelligence in the data center? So we just talked about some of the general benefits of an intelligent infrastructure from a layer 1 perspective, campus, enterprise, data center. Now, focusing on the data center. So intelligence really means we're able to support both LC and MPO for cabling, patch cords, and modules. We can decommission servers, right? How come I didn't say we can commission servers? Because typically when you don't decommission a server properly, you have cabling which is left in place, falsifying what you think is an open port because it's plugged into a switch, and you really don't know if that patch cord is active or not. And the reason is, well, of course you know, right? It has light. Well, if a PC or a server is turned off, you're not going to see light out of that port, right? So it may give you a false positive. So route and service designation, right? So we can go ahead and deploy cabling channels in one of two ways. We can say, I have a service that I need to deploy. It's a LAN service, it's a SAN service, it's a backup service. I need it to go from point A to point B, and I'll let the system figure out the points in between. Or what we can say is, I have a port on a patch panel and another port on a patch panel, and I want to provision these two particular ports the shortest possible way. All right, so we have the option to define the routes, define the algorithms to which our route and service designation, the work orders for these jobs are actually implemented. Of course, there's always a dashboard. We set thresholds for capacity, switch capacity, panel capacity, cabling capacity. I keep going to this. 10 gig to 40 gig is more fiber than 1 gig to 10 gig. So we need to know the capacity of the number of fibers in our network. User access. So if we have certain technicians that have access to certain areas within the data center, certain cabinets, some are secure, some are not, we can actually define who gets work orders by the access, by the physical location at which we're trying to provision those work orders. And the reporting function of, tell me what I have now, tell me what's changed from last time, tell me, forecast at the rate that I'm going right now, when I may be able to, when I have to upgrade, when do I need to add more cabling, when do I need to start thinking about refreshing switches. So now we'll start talking about these transmission alternatives, right? Multi-mode or single mode. And people say, well, what's the difference in cost, multi-mode and single mode? I don't really care, right? Whatever the optics are, right? As we can see here, there's a major difference at 40 gig between multi-mode and single mode. Density. We talk about density now from layer 1 all the way up the physical layer. 16 ports per card versus 3 to 4 ports per card, right? So that's on a single card level. Think about how many ports your data center is going to need and how many cards your network switch can support, and the cost of the switch chassis as compared to the switch cards. Power. 1.5 watts per port versus 8 watts per port. This reminds me of when 10 gig access to the server came out about 3 or 4 years ago, and we said, oh, power. We're migrating. We're going from 1 gig to 10 gig, and we don't want to use twisted pair cabling. It's too much power, right? This is the same decision, right? It wasn't on an individual basis. It's on an aggregate basis on all the number of connections in your data center. From a cost perspective, depends on a considerable amount of things, but the cost for single mode is considerably higher than multi-mode. Now, distance is something that single mode optics are certainly better at than multi-mode, but we need to know when it's appropriate to use the single mode versus multi-mode. This 150 meter option here is based on that SR4. If we brought into the CSR4, those numbers would go a little bit higher. That would be a 400 meter number right there. So what are some of the economics? So we just talked about generally comparing multi-mode versus single mode. This is where the rubber meets the road. This is a cost normalized of 10G base SR on the left and 10G base LR on the right. Now these aren't hard numbers. So it shows you right on the right-hand side, 100 gig over single mode is considerably higher. I like to see hard numbers, right? I like to see just how much higher single mode versus multi-mode. This is a great slide, and I know the numbers may change, between distributors, between your channel, who you procure from. But as you can see, the cost of a 40G base SR multi-mode versus single mode is pretty different. And as you move to 100 gig, and even though these are estimated 100 gig, 100G base SR10, even if they're slightly higher, it's still going to be considerably lower than what today what you can purchase from a single mode. So we're getting toward the end here. We're going to wrap this up. Let's talk about some of the components of the conversation that you can have, you can bring back to the people that are responsible. If you're not responsible, if you are responsible, to people that aren't responsible, that you can kind of justify why you're making some of the decisions that you'd like to make. So how do the intelligent buildings and computer rooms and campuses and the enterprise data center, how are they going to start to resemble each other? Some of the networking gear that lives in the campus computer rooms, you'll start to see that in the data centers, and vice versa. So when we talk about higher speeds at the end devices, when we talk about that 10G LAN on motherboard, how do we prepare for this migration 10 to 40 or 100 in the campus and the data center with respect to access and core? How do we manage these multi-form factor environments intelligently? Do we have 2 fibers, 8 fibers, or 12 fibers, or 24 fibers available on our infrastructure to deploy? And this really isn't day one. Day one, greenfield, we know we have capacity. This is day 2. This is day 3. This is after we've refreshed network equipment once or twice, and we want to reuse our permanent link infrastructure. When should we deploy LC? Or when should we deploy MPO cabling? And then again, some of these power considerations for multi-mode. Pre-term versus field term. I'm going to bring this up and kind of wrap it up just here. I didn't have a slide on this, but I want to make the point that when people say, oh, pre-terminated cabling, it's going to cost me a lot of money. And if I need pre-terminated cabling in multi-mode, well, why wouldn't I just go single mode? The cost of the optics plus the cabling for single mode versus multi-mode, the cabling gets washed out in that, in either of those instances. Right? The cabling is a small percentage of the actual channel. And then really preparing for 40 and 100 gig networks based on the distance, the form factor, and the power will ensure a successful network upgrades through multiple generations of network equipment. So, we sat here for about 30 minutes, spoke a little bit about what the migration looks like, and we'd just like to open it now for questions. I think we have a mic going around in the back. Do we have any questions? You guys have my contact information. Question in the back?
So I'm not going to claim to be the technical guy, but this is a stupid question. I think this is a stupid question, but rather than using all that fiber, why wouldn't you just put in 4 links of 10 gig rather than dedicating 12 fibers to 40 gig? I mean, because you get longer distances and everything.
Correct. So that piece, if you're not concerned about, let's go back. Let's go. If you're not concerned about losing, there's an equation, there's a cost, right? The cost of running, even though it says 100 gig, you can still, let's just pretend these are 40 gig optics, right? The cost on the infrastructure side is considerably less, right, because you don't have that transition module to go from an MPO to an LC. And if you take the cost of the whole entire channel out, this particular product is where you're going to see a lot of your cost. And we may have froze this up here. Right, so these modules right here are where most of the cost comes from. So your question was, why don't we maintain this versus moving to something like this or something like this? So that's correct. So you want to use 100% of your fiber. So this particular solution right here allows you to take two 12-fiber permanent link trunk cables and transition them to 3 8-fiber cables. And when you use the extended reach transceivers, you're able to match those distances that a 10 gig transceiver would allow for. And you're also allowed to do 10 gig in this configuration at those distances. So that was a very good question. And like I said, this is, I put this in to try and confuse people a little bit, because it's not quite as simple as that upgrade from 1 gig to 10 gig when all you did was replace the SFP with the SFP Plus. In fact, you could use the same patch cord if you'd like to. This is a different conversation that we're having. Do we have any other questions? Speak up so we can get this. Yep. Yep. So that's really a question of when the electronics, the people that make the optics, can get a cost-effective 25, 4x25, and it will be in the form of a Qsfp, and Qsfp is a quad SFP, right? So whether you do 40 gig or 100 gig, it's still 8 fibers. So in the near future, there will be some more clarity around 2x12, 1x24, or 1x8 for 100 gig. If you install pre-terminated cabling today, even if it's on a 12-fiber infrastructure, you'll be able to handle any of those different options. And if option 1 is a row of cabinets that use the 2x12, and option 2 is the 1x24, and third generation would be 4x25, you're set if you maintain the rules of the 12-fiber infrastructure. Do we have anything else? Thank you guys very much. I certainly appreciate the time. I know it's late in the day.